Good morning, everyone, and welcome to the 28th ETP4HPC webinar. I am Pascal, ETP4HPC's communication manager, and my colleague Mike is also here online to help run this webinar. And for those of you who are not familiar with ETP4HPC, we are a non-profit association that promotes European research and innovation in HPC. And we are a private member of the EuroHPC JU. So before we start, sorry, I'm trying to get to the next slide. Doesn't seem so easy. Yeah, here we are. So before we start, I have a couple of practical information for you. This webinar is recorded and you will receive the link to the recording and to the slides later. This webinar is in listen-only mode. But you can use the GoToWebinar control panel that's illustrated here to ask questions. Okay, that's the orange arrow. So I know the interface of GoToWebinar has changed. At least it has changed for me. It has probably changed for you too. So for those who are familiar with the old interface, it's changed, but the functionalities are still the same. So if you want to ask questions, click on the icon shown by the orange arrow. And the chat is available with the icon shown by the blue arrow. So that's what I wanted to share with you before we go into today's topic, which is EuroHPC. And I'm very happy. Yeah, we were supposed to have two speakers. We will only have one today. Anders Jensen had planned to join, but he had a last minute problem. He cannot join us after all. But we're very happy to welcome Daniel Opalka. He is the head of research and innovation at the EuroHPC JU, and he will tell us about EuroHPC and specifically about his subject, about the work program for research and innovation. So I think, oh yes, and we will take questions at the end after Danielle's presentation. So you feel free to ask your questions in the question tool at any time, but we will take them at the end. It's easier for everybody. So Danielle, I will make you presenter so you can share your slide. Welcome to this webinar. We are really happy to have you. Let me, yeah, make presenter. So now you should be able to share your slides. Yes, we can see your slide, Daniel.
Thank you for the introduction, and first of all, I would like to convey the apologies of our executive director Anders Jensen, who unexpectedly can't be in this seminar today. I'll nevertheless try to cover the overall and general part of our activities at EuroHPC Joint Undertaking in the first part of the presentation, and then I intend to look a little bit more into the future, what we currently discuss in the joint undertaking with the competent bodies, in particular with our participating states, on potential activities in the coming years. So first of all, I think I don't have to introduce the EuroHPC joint undertaking to you, as you are our private partners in this activities, but just a short update. So this is the current composition of the European High Performance Computing Joint Undertaking. These are our public and private members. First of all, the European Union, represented by the European Commission, 3 private partners, where ETP4HPC obviously is one of them. And in the meantime, essentially since Thursday last week, we have 34 participating countries. So on Thursday, Israel has joined the EuroHPC joint undertaking, and this has been approved by our governing board. So it's a very broad participation all over Europe, and with Turkey, Iceland, Israel even beyond. A quick overall update what has happened in the recent past at the European High Performance Computing Joint Undertaking. We have in operation a number of world-class supercomputers. The most prominent examples are the Lumi system in Kajaani in Finland and the Leonardo system in Italy. They are both currently ranked at the top 500 list on rank number 3 and number 4, and provide our communities already with very significant HPC resources. All our HPC systems that the EuroHPC joint undertaking currently owns and operates are in the top 500 list, and overall EuroHPC became one of the largest HPC provider in the world. Beyond the existing systems, we are also growing our infrastructure with some significant extensions in the very near future. The most visible procurement that we are about to complete is the Jupiter system, which will be the first European supercomputer reaching exascale performance, and this will be deployed in Germany at the research center in Jülich. So we have just very recently signed the procurement contract, and we expect the delivery to start soon. We also plan the procurement of a second exascale supercomputer. For this purpose, we have already identified a hosting site and a hosting consortium that will operate the system on behalf of EuroHPC. And this will be hosted in France, and of course, the national contribution will come from France as well. More mid-range systems are currently in negotiations, so we have already in place some agreements, so we are just about to discuss these agreements with a number of additional countries that wish to host mid-range systems. These include, for example, Greece, Hungary, Ireland, Poland, and Sweden. Now, apart from the traditional high-performance computing, EuroHPC joint undertaking recently also initiated activities in the area of quantum computing that will be added to our HPC infrastructure. So we have recently signed 6 hosting agreements for quantum computers in 6 different European countries. That includes Poland, and there should be actually 5 other countries that are missing on this slide. And in addition to this, company Pascal has been recently selected to provide 2 additional quantum simulators within the project HPCQS. In research and innovation, we are currently managing about 40 ongoing research and innovation projects. For example, 10 centers of excellence for HPC applications, many other activities on hardware, software, on training and education, and there is a lot more to come as we will go through the presentation. Investing in European skills, I'll say a little bit more in the future, but I'm very happy to inform you that we have now admitted the second cohort of students in our EuroHPC or EU Master program for high performance computing. So we have a total of about 43 students admitted at this point in time. short overview on the EuroHPC supercomputers. We have currently 7 operational systems that provide to the HPC capacity that we can provide to the user communities in Europe. Many of them are among the most powerful supercomputers, and they are distributed all over Europe. Vega in Slovenia, Carolina in Czechia, Discoverer in Bulgaria, Melusina in Luxembourg, Lumi in Finland, Leonardo in Italy, as I mentioned already. And recently we have inaugurated Decalion in Portugal. 3 more systems will become operational hopefully soon. The first of all, Marenostrum 5, which is a pre-exascale system to be installed at Barcelona Supercomputing in Spain. Jupiter, our first exascale supercomputer to be delivered in Germany, and Daedalus is a mid-range system in Greece. I mentioned quantum computers, which we currently consider as complementary, as you can think of an accelerator module of an existing supercomputer. And in order to integrate quantum computing modules, quantum computers into our existing HPC infrastructure, we have recently signed 6 hosting agreements with a number of hosting consortia or hosting entities. You can see on the map, so we cover a significant part of Europe with these 6 quantum computers. Where now the current process is that we are negotiating the next steps with the 6 selected consortia, and will hopefully launch very soon the first procurement of the first of these quantum computers. Now, where are we on the global scale? This is the short summary of the top 500 list of June in 2022, should probably be 2023. Our fastest systems, the Lumi supercomputer, number 3 on the top 500, number 7 on the green 500, probably as an outstanding asset in our portfolio. Leonardo as well, ranked number 4, and a number of other systems all ranked above in the first 200 systems on this list. Coming soon, Jupiter, the first European exascale system. So we have just very recently, as I mentioned, signed the procurement contract for this system. It will be based on Evidence Sequana XH3000 technology with direct liquid cooled architecture. Will be installed at the Research Center Jülich campus in Germany and operated also by Jülich Supercomputing Center. And it will be composed of 2 partitions. There will be a booster module. It's a highly scalable GPU accelerated system that will use the recent NVIDIA technology, which are options for broad applications, also in particular for the emerging field of artificial intelligence. But it will also include a cluster module, which will be based on a general purpose processor on the basis of ARM technology, including significant high bandwidth memory. And this will be a chip that is the direct result of one of our research and innovation activities. This is the RIA processor developed by Cyperl and within the European Processor Initiative in the last few years. So this will be the first time that we will be able to procure technology that has a very significant European footprint. A few numbers, figures on the available resources. So as you're well aware, the purpose of all these investments in European HPC infrastructure is to ultimately provide the user communities with resources to carry out research and innovation. And we have a number of mechanisms in place how the European user communities can access these systems free of charge for open research and development, both academic and industrial user, the public sector, and in particular, small and medium-sized enterprises. The total core hours awarded across all systems is very significant, as you can see in the figure on the slide, and it also indicates a little bit of the breakdown by the individual systems that we have awarded so far. The portfolio of applications covers a relatively broad range, typically, of course, of areas that are strongly represented in the European ecosystem: biochemistry, bioinformatics, chemical sciences, earth system sciences, to a smaller extent, computational physics, of course, traditionally users of significant HPC resources, as well as engineering, maths, and computer science. We have a specific access mode for our systems, which is referred to as extreme scale access, where very large amounts of resources are awarded to selected projects that have demonstrated a significant scientific impact, but also the maturity to use advanced HPC resources in an efficient and effective way. You can see that also here a significant amount of resources has been awarded in the recent past, with the largest share consumed in the area of computational physics, so universe science, fundamental constituents of matter. Now, let me move a little bit into an area where I'm directly responsible for research and innovation activities in the EuroHPC joint undertaking. This currently covers a number of pillars of our activities: technology applications, skills, usage, international cooperation, and quantum computing. And I would like to use this opportunity to give you a little bit of an update what is currently going on, what happened in the recent past in some of the selected activities, before moving on to the outlook into our future initiatives for 2024 and beyond. One action that is yet pending for 2023 is the development of an experimental platform. And here we intend to use as a funding instrument a pre-commercial procurement of research and development for experimental HPC systems. This targets small and medium-sized enterprises that build HPC systems, so that integrate hardware to HPC systems. And we have currently foreseen a budget of about 24 million EU funds. This may change still with the latest amendment of our annual work plan. But this is roughly the order of magnitude, which adds up with the national contributions to up to 48 million euro. And this should include a petascale class pilot system. The idea of this is to design a pilot system that addresses the emerging requirements of the European HPC communities. This is in particular energy efficiency and the rapidly evolving area of large-scale artificial intelligence models, large language models, one example, for example. And to run and train those models in an energy efficient way could be one of the objectives of this initiative. We are currently in the process to discuss the scope and the needs of our communities for such a system, as well as data centers on system requirements and what would be a sustainable design of this architecture that also has a chance to be successful on the wider commercial market. You can see roughly the timeline. So we expect this to be an initiative that delivers relatively soon a real system. Moving to applications, and here we have launched one of our traditional, for a long time, ongoing flagship initiatives. This is a continuation of the series of funding programs for centers of excellence for HPC applications. In this case, we specifically focus on exascale HPC applications. And we have launched now the third call in this context within the last few years, this time on exascale lighthouse application areas with in a specific scientific domain. And the selected domains in this call are personalized medicine, digital twin of the human body, and in another area, human brain research and neurological disorders. So we expect to fund 2 projects within this call with a budget of up to 5 million at a funding rate of 50% EU funding. And you can also see the timelines of the call is currently open for submission of proposals, and it will close by the 9th of January, such that we can expect the 2 selected grants to start by the 1st of July in 2024. Another update from ongoing projects, and here I would like to specifically mention our project FF for EuroHPC that addresses the uptake of high-performance computing by small and medium-sized enterprises through a mechanism of cascaded grants. And here, I think it's fair to say this is one of the very successful initiatives that we have launched in the past to widen the use of HPC in business to solve specific business problems. So this is not about scientific excellence, it's about solving business problems with HPC. And we will carry out our final review of this project next week in Berlin, and this is linked to the High Performance Computing Industry Summit, also organized in Berlin on the 18th and 19th of October, where also a live stream will be available for those who are interested to listen to the presentations. The European Master Program for HPC, addressing a very critical topic in HPC. This is the development of talents, and of course this is only the starting point in this pilot phase. But we have recently evaluated the projects with a specific issue review a few months ago. We are currently doing the formal review that was scheduled after the first 18 months of the project. So this is happening right now. The consortium is currently in Luxembourg and reports to the responsible project officer. So we will on that basis also decide and define a potential subsequent call for the continuation of this program. Now, having talked about the FF for EuroHPC project and supporting the innovation potential and competitiveness of small and medium-sized enterprises, we plan a continuation of this activity or a continuation of this concept with some modifications now under the umbrella of the Digital Europe program. And we have launched in this regard a call during the summer on financial support to third parties. Third parties in these cases are small and medium-sized enterprises through open calls to stimulate their innovation potential. On the one hand, this will continue to empower SMEs to use and benefit from advanced computational capabilities to develop their business models. But we have also added a second track in this call to support the development of large-scale artificial intelligence models, also by SMEs or startups, to benefit from and to learn in particular how to benefit and take up the existing or upcoming HPC capacities in Europe, and in particular those provided by the EuroHPC joint undertaking. So for those we provide quite significant resources, up to 3 times 200,000 euro, and we have allocated a total budget of 13 million, completely funded by the union. So this call is currently open. It will close by the 7th of November, followed by an evaluation, and we hope that this project can start in the first half of next year. Quick overview: which calls are open, which are forthcoming, where are opportunities to participate. We have currently 3 open calls in 3 different pillars of our research and innovation activities. First of all, on skills and usage. I just explained in a little bit more detail the cascaded funding mechanism to support competitiveness and innovation potential of small and medium-sized enterprises as a coordination support action with 30 million funding. We have currently open another call in the area of technology on an innovation action in low latency and high bandwidth interconnect. So as probably most of you are well aware, this is a very critical component in HPC systems, and we intend to fund this action with up to 30 million funding from the European Union, which adds up to a total indicative budget of more than 80 million euro. And finally, the Centers of Excellence for Exascale HPC applications, where we expect 2 grants in 2024. Now, having discussed the work in the past, the ongoing work, I would like to use this opportunity to provide you a short overview into our current planning process for the initiatives in our work program 2024. These are ongoing discussions, and what you will see on the next slides should be merely considered as a sort of first collection of input from our stakeholders, in particular our participating states, European Commission, other bodies, other communities. Our advisory groups have provided feedback already, but we are still in discussions with the relevant parties, and no decision has been taken yet on any actions. So for now, this is a proposal, and you will see many of the elements are not yet maybe fully consistent, and we are still working to convert this into a more consistent and coherent strategy. A few words on the process. So to give you an idea how we develop our multi-annual and annual work programs and strategies. So the key element, the key input for all these activities is our multi-annual strategic program. This is a document that is prepared by our Industrial and Scientific Advisory Board, which consists of 2 advisory groups, the Research and Innovation Advisory Group, RIAC, where also ETP4HPC is represented, and the Infrastructure Advisory Group, where members are being appointed by our public members, by the participating states and the Commission. This multi-annual strategic program is prepared by these advisory groups, adopted and discussed by our governing board, and this happened earlier this year, which is also the starting point for our preparation of the first concrete actions in the following work programs. So the multi-annual strategic program defines more the wider overview the long-term strategy, whereas the annual work program identifies specific actions pursued in a specific year. So the annual work program is based on the multi-annual strategic plan, and we have started these discussions already earlier this year over the summer. We discussed this with all the participating states in a number of meetings, in a number of workshops with experts, involving also feedback again from the research and innovation advisory groups, from the infrastructure advisory group, and we are just about to finalize the first version of this work program, which will still contain for many of the activities the abstract of the planned activities, which will be filled later where we will take into account the most recent developments in the respective field. There are a number of activities that are already agreed. So the joint undertaking will launch a procurement for a second exascale supercomputer based on the selection of the hosting entity in 2023. This is the Jules Verne Consortium in France. The JU may launch a number of procurements for mid-range systems, so this is yet to be confirmed. There are discussions going on with the involved countries and consortia. We will evaluate a number of proposals to select new hosting entities in a number of areas, mid-range systems, quantum computers as well, which we will procure in 2025 and 26. And we will launch a procurement. Actually, we have already launched a procurement for federation services for our supercomputers and quantum computers, and we plan to launch a procurement for the hyperconnectivity of our infrastructure. So this is to provide high bandwidth interconnects between our different hosting sites and supercomputers. Finally, the Access IT platform. This refers to managing applications for resources on our HPC infrastructure. This is more an internal activity that we need to process in an efficient way the requests from our user communities to apply for resources on our supercomputers. The budget. This is, of course, in a way sets a significant part of the scope of our work program in the next year. These are indicative numbers, what we expect in the following years. So as you can see, we will receive significant amount of money, about 125 million euro from the Horizon Europe program in 2024. We expect about the same amount in 2025, whereas from the Digital Europe program funds is less balanced. So we have less, about 75 million in next year, and expect a very significant contribution in 2025. Similarly, we receive funds from the Connecting Europe facility for 2025. The plan is about 100 million to implement our activities in the area of hyperconnectivity, federation, data connectivity. So all this obviously needs to be matched by national contributions in most activities. So what's next regarding our supercomputing infrastructure? Calls for expression of interest. We plan to launch a call to develop the first, or to procure the first post-exascale system. This will start as usual with a call for expression of interest to host such a system, and then we'll follow in the second step with all the activities related to the procurement of the systems. So we plan with about 400 million euro in 2025-26 for the procurement of such a system. We have currently in our draft work program a fourth call for expression of interest for mid-range supercomputers, and there are currently discussions whether we should take a little bit more strategic approach on the selection of technologies and possibly target in this call specific application areas complementary to our existing infrastructure, for example, artificial intelligence. And we have allocated about 20 million for this. A second call for expression of interest for an industrial EuroHPC supercomputer with a focus on artificial intelligence, maybe also launched in the work program next year with a selection and procurement in 2025. So for this, of course, we need also an industrial consortium that is willing to cover the remaining 65% of the acquisition cost, as our funding rate is limited here to 35%. Quantum computers is another activity that we continue also in work program 2024. We intend to launch a third call for expression of interest to host a EuroHPC quantum computer. This will follow the similar procedure as preceding calls. We would like to increase our portfolio of quantum computing technologies, and then this will be followed by a selection and procurement in about 2025. And we are currently also discussing with our communities and stakeholders to what extent new technologies are sufficient or will be sufficiently mature by the time we will launch the procurement, and how we can further develop our portfolio of quantum computing infrastructure. We potentially will also launch a call for an upgrade of EuroHPC supercomputers with specific artificial intelligence capabilities, in particular those that haven't been upgraded yet. And this may be an activity that will result in a procurement in 2025. So we have foreseen currently about 60 million for this. Research and innovation. So I will now very briefly talk you through a number of initiatives that we may further elaborate in our final work program 2024. And one of the concepts that is currently under discussion is the development of new benchmarks for high performance computing, quantum computing, and artificial intelligence. And here I think you have to understand that these three technologies are very different when it comes to benchmarking. So the area of HPC has already many well-developed applications, well-established benchmarks. LINPACK is one of them, although this may not always reflect the actual user requirements. And the idea is here in the area of HPC to create a portfolio of application-oriented HPC benchmarks that can be used to compare HPC systems to assess the value for a certain usage portfolio that is expected by the respective communities, and also help potentially in more technology agnostic or technology objective procurements by not, for example, discriminating against certain technologies. Quantum computing, very different level of maturity. There are no meaningful benchmarks established yet, and here, of course, also our ambition is to first identify useful benchmarks that reflect potential real use cases and user requirements. So in a way, also more application-oriented benchmarks, but this will happen at a very different technology readiness level as for HPC. So this will almost certainly result in a different grant. So we will most likely award different grants in this activity for the specific technologies. Artificial intelligence again comes with different requirements, and here again, even within artificial intelligence, with hardware is supposed to be benchmarked or system architectures. It's important to distinguish between the training of large-scale AI models, which has different requirements, than operating a large-scale AI model. Inference is here the technical term that refers to this. So, and in both cases, benchmarks can be very valuable, and we may ask the community to work and propose meaningful benchmarks in this area. Further on quantum computing, we will continue our commitment on the integration of quantum computers into HPC systems. This has started with a research project, HPCQS, in the last years and continues as part of the procurement of our first quantum computing infrastructure. And with such an activity, we would like to continue these developments, also to start to some consolidation of the different solutions. Currently, our communities pursue different directions of this integration, and this could be a starting point to work towards a more common European reference software stack that makes both the system administration and management more effective, but also provide a more harmonized and technology agnostic user environment for our HPC and quantum computing infrastructure. High performance computing for artificial intelligence. So here the idea is to provide support for the development of artificial intelligence related software. We understand that there are many solutions. Many of them are open source, others are controlled by certain entities. But in many cases, these software packages, these tools, libraries, workflows cannot yet run efficiently on our infrastructure. For example, there's further development needed. Maybe there are some gaps that need to be filled. There needs to be done some work on scalability. Also in the specific context of our systems, there needs to be some integration in EuroHPC federated services and much more. And this will be a software development activity complementary to a second action that I will talk about on the next slide, on an artificial intelligence oriented support center. Or maybe not on this slide, but in one of the following. HPC applications for the exascale era. So applications is a topic where we receive continuous feedback from our stakeholders, from our advisory groups, from our communities, that this is a very important, very critical area to develop the HPC ecosystem in Europe. And in this initiative, as we envisage it for now, we wish to provide support that is complementary to our flagship initiative of Centers of Excellence for HPC applications. So there are a number of areas for HPC applications that are not covered by Centers of Excellence, that may not be covered by Centers of Excellence because the community lacked a critical mass for such a scientific domain-centered large consortium involving many different applications, all centered around the same scientific domain. So here we would intend to work with smaller grants and focus on individual HPC related applications, including also artificial intelligence, big data, machine learning, potentially cybersecurity and other applications. We are also considering to open a second topic in this call on software libraries, which is in line with our multi-annual strategic program that aims to increase the modularization of our HPC software ecosystem to make components more reusable, to share more code, to share more software between applications. So there may be two topics in this, and we are currently considering about 20 million EU contribution for this topic. Support Center for Artificial Intelligence, as indicated before, this is an initiative that we may launch already very soon. The purpose of this is to help our communities, to support our communities, to bring their applications, to scale up artificial intelligence applications, bring them to our infrastructure, to adapt them, to run effectively on our infrastructure, and then ultimately, of course, create value from using our infrastructure through our access modes, extreme scale access, regular access I have talked about earlier today. So we provide these resources free, but we need to educate and support our communities to help them how to apply to these free resources, how to get access, how to use them in an effective and efficient way, and potentially even help them with the scaling up of their workflows from the laptop or from the desktop system to our HPC infrastructure. We also received requests to include activities in the area of HPC and cybersecurity. This will also involve almost certainly a certain amount of artificial intelligence technology. This is at a very early stage, and we are currently planning to launch discussions with our relevant communities to better understand how we best set the priorities here, whether this should aim to secure our own infrastructure, for instance, by real-time threat prediction, incident response, identification, and to monitor user behavior, other security critical components, or whether this should rather aim for research on new technologies that can in general support cybersecurity activities beyond our infrastructure. So, and there are probably many other options. So this is an ongoing discussion, and we'll certainly have many feedback loops in the near future. Continuous integration and deployment platform, it's also planned for next year. So the EuroHPC plans to set up a platform, a software repository in particular for many of the software applications that are developed within an open source or permissive license context. And almost all of our application projects already operate their own continuous integration platforms. The purpose here is to connect all of those into one single platform, consolidate this, and use this to deploy on a regular basis applications to our systems, and therefore achieve a broader availability of software for the users as they apply to for access. I spoke a little bit about the EU Master Program for HPC. That's, again, we are currently reviewing the existing Master Program for HPC. We will certainly make some adjustments as we move into a potential next phase. But here it's a bit too early to speak about the specific content. But at this point in time, we have the ambition to continue this program also because we understand creating a new master program and establishing the required visibility to make this attractive takes more than just a few years, and we are working on this. International cooperation, this is pretty much my last slide, before I conclude this presentation, is in general based on digital partnership agreements that the European Union agrees with a number of countries and regions all over the world. We know that a number of those are already in place, with Japan, for instance, South Korea, Singapore. There are agreements with India, and there are many others currently negotiated. We have launched already international cooperation with Japan in a project referred to as Hanami, and we will very soon launch a call for international collaboration with India. This will also focus on applications primarily. At this point, no activities in hardware are planned, for example, quantum computing or microprocessors. This is something that may be considered in other cooperation mechanisms, or perhaps in a next phase. So with this, I thank you for your attention, and I'm happy to answer your questions.
Thank you, Daniel. Thank you for this presentation, and thank you especially for the insights into future future calls, because I know that that's what our viewers really like. That's what they appreciate most. So well, I'm trying to share my screen, but it's time for questions. Here we are, share. So you can enter your questions into the question panel. So we already have a question actually. You touched upon EU Master for HPC at the end of the presentation, and we had a question about it from Thor Wickfeld. Will there be a follow-up, that is a EU PhD for HPC?
That's a good question, and
Yeah,
I
I think
think
it's a very good question.
so. The first question is, of course, when we think about PhD programs, this is certainly not a program like the EU Master with a curriculum with joint degrees or similar. So to me, this sounds, if I just hear this as a proposal, this sounds more like a scholarship program. But in fact, for now, we have no plans to launch a specific action targeting PhD students. So we have a number of activities covering also PhD students. For example, we have launched very recently a call on traineeships that address also the PhD students that wish to, for instance, either have an internship in a private company or possibly in a research center or in the public sector. But this is broader than just PhD students. So it also targets, for example, professionals that wish to develop their career.
Okay, thank you. Any other questions? Because I don't see any question coming in. Come on. This is your opportunity to ask your questions directly to a representative of the EuroHPC JU. No? No questions? Okay. Maike, did you have any question before we close? Oh.
No, thank you. Thank you very much. I think this was a very detailed presentation. And I think there are really many calls to come and very interesting calls to come for our community.
Yeah.
So I think the important point really will be sort of perhaps to follow up on this later once we have more details on the call and support the community in submitting interesting proposals so that we can make the most of the money and benefit as a community the best we can from the funding.
Okay, I just had a message, a question, but it was sent to me privately in the chat. I will read it to you. What are neuromorphic visions from EuroHPC? Do you have any vision about neuromorphic technologies? And he explained, it's from Thor Wickfield, and he explains, I mean, you discussed quantum, but not neuromorphic. Anything to say about this, Danielle, or?
So in general, we are open to emerging technologies, and I think what you have also seen in the presentation, that we adapt to the development of new technologies. We now will very likely develop and procure specific systems for artificial intelligence, for example. We have now also launched procurements for quantum computers, and we may do, in fact, the same for other emerging technologies such as neuromorphic computing. What matters for us is typically that the technology must provide a sufficient technology readiness level that we can procure it. We see this currently with our quantum computing infrastructure, that in some cases the technology may be not as mature as we thought it might be at this point in time. And also, of course, we depend here on suppliers that can deliver this technology to our supercomputing centers, for example, as a module that is part of an HPC system. And here, at least to my knowledge, I think we need to first better understand the market and whether there are opportunities for us, and whether also our users will be able to benefit from this.
Okay, yeah, that makes sense. Well, thank you very much. So if there are no other questions, I think we will close for now. I would like to thank very much Daniel Opalka for being here today and for preparing this presentation of what's coming from EuroHPC JU. I'm sure our audience really enjoyed this. Our next webinar is on the 27th of October, and it will be on Lumi. For those of you who registered for the date initially planned for this webinar, we had a technical problem, so the webinar on Lumi will happen, but on the 27th of October. So I hope to talk to you later in October. So thank you again, Daniel. Thank you, Maike, for supporting me. And thank you, everyone, for attending this webinar. We had a good number of attendees today, really very good. Thank you, everyone, and bye-bye.
Thank you. Bye.
Did you stop the recording?